Hello, this is Farhan Khan from the Republic 2.0, and we've been doing the Edexcel level physics unit 1, and today's topic is resolving vectors. In the last video, we talked about how we can add two or more vectors by using head to tail rule, by using the parallelogram rule. These were the rules we have already talked about. Now, the next thing that we're going to talk about is that how can we resolve a vector into its components and how can we calculate their magnitudes. So whenever you're talking about the resolving vectors, what does that mean? To split a vector into its perpendicular components. To split a vector into its perpendicular components is basically known as, this phenomenon is basically known as resolving vectors. And how can we resolve them? Now, for example, if we've got a vector which is something like that, right? And that vector is making an angle of, for example, 30 degrees with the horizontal. So how can we make up this vector? I'm just going to move backwards. So by using head to tail rule, this vector can be made by just adding a vector like that, and then by connecting another vector on its head like that. So if this is a vector F, and the magnitude of F, for example, is 5 newtons. So this is going to be the horizontal component of this vector, and this is going to be the vertical component of this vector. And by using fx and by using fy, we can calculate f. So now, what we can do, for example, if we're talking about reasons to calculate f, we can just simply write down some simple trigonometric ratios. From this triangle, everybody knows that sine theta is so, right? Opposite over hypotenuse. The opposite side over here is fy, and the adjacent side is f. So you can simply calculate fy, that is going to be f times sine theta. So now you've got the force. The force is 5 newtons. You've got the theta, that is sine 30. So by just multiplying them up, you can get fy. And similarly, if you want to calculate fx, which is the horizontal component of f, what you're going to do now, for example, if your f is 5 newtons, so, if you want to calculate fx, you have to take cos theta. Everybody knows that, so toa. So cos theta is going to be adjacent over hypotenuse. The adjacent side is fx. The hypotenuse is f. You can just simply get fx by switching the side of f, so it would become f cos theta. So fx is going to be, you've got your f, the force is 5, and the angle is 30 degrees. So that is how you can get yourself the perpendicular components of this vector. Now, this is the one method to do it. Now, for example, if somebody is not interested in this angle and you've been given with the angle with the vertical of this f, what we're going to do now? I'm just going to draw the same force again. But now, the angle with the horizontal is not given. And what is given? The angle with the vertical. And this angle, let it be 60 degrees. Now, everybody knows that this is going to be the vertical component, and this is going to be the horizontal component, which is going to be fx. Now, in this case, if you want to calculate fy or fx, keeping in mind that this is the same vector, which was of 5 newtons, how can you calculate that? So if you want to calculate this fy and fx, in this case, you can see that the vertical component is fy, and fy can be used, can be calculated by using, since this is a adjacent side, this is the adjacent side of the angle. So for calculating fy, for calculating the vertical component, this time I'm going to use cos theta. So cos theta would be equal to so ka, adjacent over hypotenuse. Adjacent is fy, and the hypotenuse is f. So fy this time going to be f cos theta. So the matter of telling you that either we're going to use sine theta or cos theta, it depends upon the angle given, right? That angle is with the horizontal or is with the vertical. So it depends upon cos theta over here. So if you want to calculate fy going to be 5 times cos 60. And similarly, if you're going to calculate fx, that's going to be 5 times sine 60. So the point which I want to tell you guys is, for example, if you're going to calculate fy and fx, many hold the simple convention that every time you're going to calculate fy, use sine theta, but that is not true. The angle might be given with a vertical, right? So if the angle is given with a vertical, we can use cos to calculate fy. If angle is given with a vertical, we have to use sine with fx. So cos and sines are not fixed. You have to use your common sense to get yourself the final results. So that is how we're going to do these questions. And now, for example, in any of these questions, you've got the magnitudes of the perpendicular and the vertical components, and you want to calculate the final vector. For example, that is the hypotenuse. For example, this is a vector which is f. There are two vectors which make up f. For example, one of them is 5 and the other one is 12. You just need to use a simple Pythagoras theorem to calculate the resultant vector. And that is going to be f is equals to fx square plus fy square, right? So f would be the square root of fx square plus fy square. So that is how we're going to calculate the force, which is going to be the square root of fx square plus fy square, right? So that's it. This is how we talk about the resolving vectors like this. Now, for example, let's talk about an example. Uh, and we have to take an example of a submarine that is moving downwards. Like, for example, this is the ocean, some sort of ocean. And then we have got a submarine which is inclined, for example, like that, moving in this direction. And the angle it is making with the normal drawn at that point, that angle is 45 degrees. Now, for example, there could be different instances. The captain of the submarine wants to calculate that how fast we are approaching towards the seabed. So if you want to calculate how fast you're approaching towards the seabed, you have to calculate the vertical component of the velocity, this component. So if you want to calculate this component, I'm going to just make up a quick right angle triangle. So if you want to calculate this component, which is going to be Vy, what you're going to do, you just need to use, cos 45 equals to SOHCAHTOA adjacent, which is Vy, divided by the hypotenuse. The hypotenuse could be this velocity, and that becomes V. So Vy this time would be V times cos 45. Now, for example, if the captain is interested in calculating how much distance horizontal, how much horizontally we're going to move. So you can use sine for that. Sine 45 would be equal to Vx upon Vy. So you can have the horizontal component of the velocity. Sorry, V only. So Vx gonna be V times sine 45. So that is how we're going to calculate the horizontal component of velocity. And that is how we're going to calculate upon the vertical component of velocity. The point to be noted over here is that cos theta is not fixed with the horizontal component. Sine theta is not fixed with the vertical component. It all depends upon the given angle. You have to use your prior knowledge of trigonometry to see whether you're going to use the cos component or whether you're going to use the sine component and the given data in the question. Thank you very much. I hope you guys did understand it. Uh, Please, like, subscribe, and share this channel. Thank you very much.